So in this video, I want to talk about probability. So what is probability? So probability is defined in terms of events. So an example of an event would be a specific passenger on the Titanic survived or didn't. Or you flip a coin and you see that it came up heads, that's an event. If you see that it came up tails, that's an event too. Probabilities are defined in terms of events. So for example, if we're talking about some passenger on the Titanic would say that the event here is that it turned out that they survived. And the probability measures, and that's going to be a little bit tautological, but kind of how likely it is that the event occurred. So we're saying 40%. So what does it mean? That's actually a kind of complex philosophical issue on which there is not quite an agreement. But one kind of approach would be, well, if you could repeat the same circumstances again and again, so you would send this passenger to sail on the Titanic again and again, you could ask, well, in what proportion of those repeated trials did they survive? So with a passenger on the Titanic, that sounds a little bit ridiculous. With a coin that you flip, that actually sounds pretty reasonable. So what's the probability of heads in a fair coin? Well, it's 50%. Why is that? What do we mean? Well, we mean that if we flip the coin a whole bunch of times, then half the time, 50% of the time, it'll come up heads, and half the time it'll come up tails. So while probability, the definition of probability is a little bit tricky philosophically, and some people kind of claim that the definition that I gave you is either incoherent or it's just not applicable to most real life situations, because most real life situations, sailing on the Titanic, that's not something that you repeat the way you flip a coin multiple times. But a lot of the time in practice, kind of what we really mean is, well, this number, so 0.4 in this case, it kind of measures how much do we think that survived is equal to 1. And the answer here is, well, 0.4. And if we were sure that survived is equals 1, then this would be 1. If we are sure that it's not, then it would be 0. And then here it's something in between. So that's another way of thinking about probability. So with that way of thinking, though, you got to be a little bit precise, and you got to say the most important thing with probability is that the probability of something happening, of the survived variable taking on some value out of the possible values, is 1. So it must definitely be the case that P of survived equals 0 plus P of survived equals 1, that must be 1. So what follows from that is that the probability of survived equals 0 is 1 minus the probability of survived equals 1, assuming, of course, that survived is a binary variable, that it could only take on the values 0 and 1. So we'll go with that. What this number measures is how sure we are that survived is equal to 1, and here we're not sure at all. In fact, we think that more likely it's the other way. And the sum of probability of survival equals 1 and the probability of survival equals 0 has to be 1, right? Because one of the other is going to happen, and if survived equals 1 did not happen, it must be survived equals 0. So those two must sum up to 1, which leads to this.